This week, scientists in New Jersey and around the world are cheering the first tests of a multi-billion-dollar particle collider. By briefly creating conditions thought to have existed just after the Big Bang, the collider could help scientists answer some really big questions. Science and technology correspondent Patrick Regan reports.
This week's milestone for CERN's Large Hadron Collider, the one-way launch of a relatively low-energy beam of protons around a 17-mile ring, marked the beginning of critical engineering and safety tests. The excitement it has generated comes from the prospect of answering big questions that involve cosmology as well as particle physics. By smashing together opposing proton beams, each moving at nearly the speed of light, the collider will test theories describing the large-scale evolution of the universe, as well as the fundamental constituents of matter. One big question concerns subatomic building blocks called quarks.
If they're fundamental, why do they all have greatly different masses? Masses ranging by a factor of 1,000 from the heaviest to the lightest.
Another big question, according to Princeton physicist Stu Smith, is what happened to antimatter produced in the Big Bang, gone today. The collider may also shed light on the so-called dark matter, observed indirectly on cosmic scales, but as yet unidentified.
So that this dark matter particles, what could they be? There's 5 times as many of them as are the kind of matter that we know about. If we succeed, then this would mean that we would know the origin of mass, we would understand where the antimatter went, and most importantly in some ways, we would understand where a much larger fraction of matter resides in the universe and what it is than even all that we've been able to discover so far. But if it turns out that nature is not as predicted, and that is more often the case than not, it also sets up a tremendous set of new questions.
Patrick Regan, NJN News, Princeton.